Hello everyone and welcome back to the Row Programming channel. Today, we're going to tackle the second part of score management, where we'll display the score using sprites. So, we left off here last time, and we can see that the memory stopped at 08EF. So, we're going to be able to place our sprites with the indexes 40, 0 which are located at $0A00. And we'll start right away by defining our variables. So, there you go, sprites 40 and 41. So, the first thing to do is to display the sprites. And the sprite positions are located at $D000, $D001, etc. And the color at $D027. We'll position them at 100 and 124. And at a height of 200. We'll set them to white. And so all these variables, I'm going to define them here as well. There. Now we need to activate them. So to activate them, it's bits in $D015. We have two sprites. There. And we activate. So now, we're going to display our sprites and we'll check right away if everything is working. We have the sprite displaying. Good. Second step, initialize the sprites. And the first thing to do is to clear their content. By the way, I'm going to rename 0 and 1 like for the coordinates. And the size of a sprite is 3 times 21, that's 63. There, a simple loop. We must not forget to initialize the pointers to sprites 40 and 41. And it doesn't work because here it's not $3F0 but $3F8. My mistake. There, they are properly initialized and empty. The easiest part is done. Now we're going to draw the sprite content. So, we have the choice between using a custom character set or the default character set. So here, this video isn't meant to talk about custom characters. So we'll use the default character set. And by the way, the sprite clearing, I'll put it here. Yes. So, how do we draw our sprites? We're going to erase the previous score. And we're going to redraw each character from the ROM corresponding to the digits to display. So, initialize score sprite. So to draw, we'll need to locate the character in memory. 0, 1, 2, 3, etc. Define the memory location where the sprite is to draw our character, and finally draw this sprite. To define the character, we're going to use the same method as for classic characters, which will allow us to have either a space or a character. And so we'll use the same method again. We use set_number_space again to know if it's a character or a space. So that will be our loop for the sprites. That. Now, we're going to define the memory location to fetch the characters from. And we'll place this in page 0 at $67. And we'll do the same thing for the sprite position, which we'll place at $69. So for the sprites, we know the position, it's score_SPR0, score_SPR1. For the characters, we need a buffer. That will put at $6 billion, which will indicate which character to use. We set it to 0. To initialize. And so now, we're going to define. Based on that, the position in our sprite. And so since we defined the initial position at the very top, we're going to define the next position here once it has been drawn. So we increment tmp_char. We know that the first three characters 0, 1, 2, 3 are for the first sprite. And the next three will be on the second sprite. There. So if we are on the second sprite, we initialize it with SPR1. And now, we'll be able to fetch the character to draw. And we know we'll need to draw it in SPR_MEM. So before getting there, we need to save y. To be able to do the loop of 8 bytes. There. So my registers, I'm going to save them here. So I create the 3 like this so I won't be bothered later if necessary. Okay, I still have no errors. So everything is fine, it compiles. Here. I forgot to do the JSR draw_score to draw. Hop. There. So we can see that it's trying to draw things in the sprite. Well, we haven't done a loop for the moment, so of course not much is displayed, but we can see a change that more or less corresponds to the change we see on the digits at the top of the screen. Okay, so here we have an STA, we still don't know where the character to copy is located. And so for our loop, we will need here to increment the sprite. And the thumb char. There. Anyway, for now, it doesn't change anything. So, locate the character to draw. To be able to access the character ROM, we're going to have to change the processor port to be able to activate this ROM. So the first thing to do is to define in memory where the character ROM is. So if it's a custom character set, of course here we'll put the coordinates of the custom char set. I'm going to save my X and my Y. So, we need to multiply the character by 8 because each character corresponds to 8 bytes. Multiply. And at the end, we're going to add our character set position. So we'll do that just with the high position. Since the low position are zeros. There. So now, I know exactly where to fetch my character in memory. So, it's not very complicated. Now, we're going to do a little loop that will fetch the content of the memory and paste it into the memory position of my sprite. So I don't initialize Y, we see at the very top that I already set it to 0. And I do my little loop. So, there's something weird, which is that for the sprite to be able to superimpose the 8 bytes as a sprite, it's 3 bytes, we'll need to increment 3 times to go to the next line. Actually, increment twice since as we are also incrementing Y, that will be the third time. And we can see now that we have a very square character. Indeed, we don't see the character for the moment, but we are on the right track. I don't forget at the end to retrieve my X and Y registers. Good. So, there's something weird. We don't see the character, and that's completely normal because, as we saw earlier, the character set is located in a ROM memory position that must first be activated via the processor port. Here. And we must not forget to deactivate it at the end of our processing. There, we have our digits. Well, it's a bit erratic, it's not displaying exactly what we would like it to display, but we see characters. So now, where did I go wrong? That is good. Well, I'm locating my characters correctly anyway, that's for sure. The problem is in the drawing of the sprites. So first, we'll remove that since the display I have here. That, we'll move to an external function because we'll need it several times. If we can avoid redundant code, it's always a good thing. Unless we need extreme speed. There. So, well, by using this method, I do have my characters several times. The 2, the 9, the 8. The 2, the 9, the 8, the 7, I don't know where it went. So I think I have a problem with the increments because already my 2 and my 9 are not stuck together. So that's good. The issue comes from the definition of the next position to place the character in the sprite. So, let's look. So, first, I'm not going to completely reinitialize my score, which will allow me to see if I'm drawing all over the place. Okay, so here we can see that the first sprite has completely been zeroed out, whereas normally it was all white, and that in the second one we are not drawing everything. So, now, I do have all my digits, but I have an offset. Too bad. So 4031. So, I maybe paused it before it had time to draw the 1, but we can see that the 0 is not in the right place. So it's this whole part here that is not correct. So, I'm going to add a pre-next one, which will define the next character, the next position, sorry. So I need the same thing for next 2. And here, we have pre-next 2. And don't forget to jump to a next 2. There. Ooh, I have too many characters now. Okay. So, since I drew, I went down in SPR_MEM. So, I'm going to go back up. Well, that doesn't solve the problem. Ah, the 1 went to the right side. Okay, anyway. No, that's still not the right method. Hmm. I'm not going to use that. I'd rather use a function. That will keep the values for me. And so when we increment, we will increment SPR_MEM rather than SPR_MEM. And the SPR_MEM, I'll put it in SPR_MEM, which will allow me to keep my SPR_MEM position from one digit to the next. Ah there, that's much better. So, why do we see them erasing as we go? Well, simply because. In my code, I asked to completely reinitialize the sprites on each draw. So with the display speed, we have the issue. So, I'm going to remove the initialization on each draw, and already it's much better. There. We're going to remove now the little white square. Well, the little rectangle. And so the advantage of sprites is being able to move them on the screen. So my score, I'm going to display it and I'm going to make it move. Well, that's a bit fast. There. So, well, it might seem silly to do that right now, but imagine in a game. Your score can be in one place and when, for example, it increases, you can make it shake. You can make it go from right to left. And the additional advantage of the sprite is that you can position it outside the standard drawing area of the Commodore, all the way at the top, all the way at the bottom, as you wish. Another advantage is that you can do video effects like flashing colors, fading, or the shape doubling in height. For example, we just added to the score, boom, we double its height for a few moments and then we reduce it. You can move it from right to left, I said. So here, see, it works. Well, we must not forget to use the MSB of course, but that's in another video. It's in the videos that handle sprites. We've already seen that. I'll let you go back to them. That's all for today. I hope you found this video interesting, that you enjoyed it. Don't hesitate to give it a thumbs up, it's always appreciated. Remember to subscribe to the channel so you don't miss the next videos. If you have any questions, feel free to ask them in the comments. I answer everyone. And all that's left for me is to wish you a pleasant day. Take care of yourselves.